Hello, I'm Dr. Vernon Thielman, and I want to welcome you to Chemistry 105, Section M01, and Chemistry 106, Section M01, the TV course for the Fundamentals of Chemistry class. I should say just a word about the course. Chemistry 105 and 106 are designed primarily for students who have not had a high school chemistry course, or who have had a chemistry course in high school but maybe some years ago. You need to be certain that the course you're taking does fit with your required course in your major. Chemistry 105 with the lab does satisfy the general education requirement in the natural sciences. Chemistry 106, which does not have a lab, does not satisfy the general education science requirement. Also, you need to be certain that if your major does require chemistry with a lab, that you have enrolled for the Chemistry 105 course. If you have signed up for Chemistry 105, you should have also signed up for a laboratory section. So you not only should be signed up for the M01 lecture section, but likewise you should be signed up for one of the laboratory sections as well. There is one laboratory section scheduled in the evening, so you should be able to take the 105 course strictly as an evening section. In the first meeting that we had, you received some information relative to the course, and let's spend just a moment or two running over that again for your information. You should have received a packet of materials which included the course syllabus. And on the course syllabus, of course, are some information such as my name and my office, and office information, times I would be available. My phone number is given on that, and my email address as well. You can contact me by phone. If I don't happen to be in, after a short time it will transfer to the departmental secretary, and you can leave a message and I can return your phone call. Also, there's an email on here. The email address will be useful if you have a quick question. It's not useful in terms of me trying to solve an entire problem for you. Obviously, I can't do that on email, but I could answer a quick question, clarification of what might be on the test, clarification of a test date, clarification of some material like that. So the email is on there, and feel free to use that. It also tells what the course material required are, and so let's just look at that quickly. First of all, the textbook. The textbook that you will need to get is called Fundamental Concepts of Chemistry, the author Vernon J. Thielman, which is myself, and published by Wiley. This is available in the SMS bookstore and also in some of the other textbook locations in Springfield. The textbook will be very important in the course, so you need to be certain to get that immediately and have it available as you begin the course and follow the course through for the semester. In addition to that, you will have a student study guide, and this specifically says Chemistry 105-106, Section M01, and this is a required part of your material because this outlines some of the assignments that you will have as you go through the course. So you do need this. These are available only at the SMS bookstore, so you will need to get that at the bookstore. If you are signed up for Chemistry 105, which is the laboratory course, you will also need a lab book, and you will need to have that with you when you attend the lab sections. One additional thing, well actually two additional things, but the first, a calculator. Chemistry is fairly problem-oriented, and so you will need to have a calculator to carry out the mathematics. It doesn't have to be a very expensive calculator. It can be rather inexpensive, but there are two buttons on there that you should look for when you purchase one. One is that it should have on it an EE key or an EXP key. This is used for when we're working with numbers, very large numbers and very small numbers, and we're going to be using powers of 10, exponential numbers. And you need that on the calculator then for the working those problems. Also, it is useful later on in the course where we will be doing some square root calculations that you might want to check to see if it has a square root button as well. Other than for those two, really multiplying, dividing, adding, and subtracting is going to be the main use of your calculator. And so it doesn't have to be very detailed, but those two will come in useful. Also, you will need to have a 8 by 11 spiral bound notebook, approximately 100 pages in length. And this is going to be to put your problem assignment in, which will be turned in at the end of the semester. So again, the textbook, student study guide, which is a required part of the course also, a calculator, a spiral notebook, and if you're in 105 course, the 105 lab manual. Also in the handout, it gave the schedule of the classes, gives the grading policy, it talks about when the exams and how they are counted, and in addition to that, then there's a TV schedule sheet in there, a test schedule sheet in there, which will tell you when the tests are given. Tests will be given on Tuesday nights, the regular scheduled night of the class, and then an alternate Saturday, usually following the Tuesday. Occasionally this might be reversed, but you need to pay very close attention to those dates. If you cannot make the regular scheduled Tuesday test period, then you need to make certain that you can make the Saturday test period. So all of that information is in the packet of information that you received in that first meeting that we had. I'd like to spend just a moment talking about, a little bit about how to study for this course. It's a challenge to take a course and be self-disciplined enough to proceed through the course totally on your own. The course will be shown on TV and 2 lectures at a time, so there's 2 hours on Tuesday night and 2 on Thursday night, and then these are repeated on Saturday, where all 4 hours are shown. Now, of course, you obviously can watch the tapes live, or you can use a recorder and record them and look at them at your own pace. Before you actually look at them, whether it be looking at them live or looking at them on the tapes, it's a good idea to scan the chapter quickly that you're going to be working on. Have some idea of what the lecture is going to be about. Then as you view it, it'll make a little more sense to you, and then as you go back to use the book, hopefully tying in what you've seen in the lecture will help. So scan the chapter quickly first. Now if we look at the chapter, for instance, again thinking about how we're going to go about studying, at the beginning of the chapter are a set of learning objectives, someplace between 10 and sometimes 20 statements of things that that chapter is supposed to help us learn. So we kind of use that as our guideline. This is what I need to find out about the course. And then when we finish the chapter, of course, hopefully that we have now covered that material, that we do know that information. As we go through the chapter, and especially in the areas where we have problems set up, we'll find that there are example problems. The example problems usually follow immediately the discussion of a particular type of problem. And the example problems are very thoroughly worked out, so it explains each step what we're trying to do. Usually immediately following the example problem will be an exercise, and the exercise then is for you to try. In this particular case, the exercise is not immediately after, but closely after. And it asks you to do basically the same problem, same type of problem. If you do the exercise, you can then turn to the end of the chapter, and the exercises are worked out for you, so you can check yourself to make sure that you are doing things correctly. And the exercises not only are answered in the back, but they are, again, set up and thoroughly worked out stepwise so that you can follow along and see what you have or have not done correctly. So they're rather detailed answers in the back of the text, right in the back of the chapter, I should say. Well, after you've gotten through the chapter and looked at the VCR tape, right at the end of the chapter is a little section called the chapter summary. And the chapter summary kind of reviews everything and outlines in bold print key terminology for the chapter, and so you would want to pay close attention to that. Then at the end of the chapter itself are a set of review questions and problems. This is where the student study guide is part of the requirement, because the student study guide now will tell you specifically which problems you are required to do to put into your notebook. And so you need to pay attention to that. The even-numbered problems are usually the ones that are assigned and don't have answers at the back of the book. The odd-numbered problems, which are almost identical, again, do have answers in the back of the text, but they have answers only. For solutions to the odd-numbered ones, again, we go to our study guide, and at the end of the study guide, we find solutions, not just answers, but solutions to the odd-numbered problems in the chapters. So you can do an odd-numbered problem, you can check it on yourself and see if you're doing it correctly. If not, you have a way of seeing what step that you might have done incorrectly. And after you've proceeded through that, and you want to kind of check yourself to see how well you're doing, the very last thing in the chapter is a chapter self-evaluation. This is just a little test. You can kind of sit down, keep your book closed, see how well you can do on the self-evaluation. Now, again, the student study guide comes into play, because the student study guide has the answers and solutions to the self-evaluation test right at the end of the chapter. That chapter. So like in chapter 1 or whatever it is, we've done the self-evaluation, we go back here, and we then have the answers and solutions to the self-evaluation, so you can test yourself. Now, in addition to doing that, there are help sessions on Tuesday evenings at the regular schedule 5:30. On the days that we do not have scheduled Tuesday exams. So about half of the weeks you can come in and get some help by attending the help session. Of course, obviously you can call me and get some guidelines also. So again, look at the beginning of the chapter, see what you want to learn. Follow through the tape. Do the problems in the chapter, the examples and exercises. Do the problems that are assigned to be put into your notebook, which will be turned in at the end of the semester. And then finally, do the self-evaluation to see how well you've proceeded. Now, with that, hopefully you will have a successful chance in the course, and that you will have an enjoyable experience in the TV course in chemistry. And so if I can be of help in any way, feel free to use that phone number and give me a call. Use the email. Stop in for the help sessions on the Tuesday nights that they are scheduled, and hopefully you will have a successful semester in chemistry. Well, so we'll go ahead and begin then our discussion this morning on Chapter 1 of the text. Chapter 1 talks about, first of all, chemistry. And so we might say, what is chemistry? Why do we want to study it? other than the fact that maybe it's a requirement in our major or minor or something. But chemistry is the study of matter. And when we think about that, that basically means the study of almost everything. The study of matter and its changes. For instance, you may wonder, why does gasoline, which is a liquid, and water, which is a liquid, not mix? Why do ethyl alcohol, which is a liquid, and water as a liquid, they do mix? As a matter of fact, this morning you had to worry a little bit about gasoline and water not mixing, because if you had a little bit of water in your gas tank and it doesn't mix with the gasoline, the water has a tendency to go to the bottom of the gas tank, would come through the gas line which is under the car, and of course could become a solid. And if it becomes a solid in the gas line, your gas flow is shut off and your car stops operating. And that's not a nice thing on a morning when it's minus 9 degrees. Or it's not a nice thing to happen anytime, whether it be the summer, the fall, or the winter, but more likely to occur at this time of the year. Okay? So you may have wondered about that. You may have wondered why certain chemicals have tastes that they have. You might have wondered why one particular chemical will react with something and another one won't. Why we can't mix some things together without it being dangerous. We can mix other things together with no concern whatsoever. And so chemistry is the study then of matter and the changes that it undergoes. All right, and we're going to look at a couple of types of changes today as we go on just a little bit later. We're going to look at physical changes, and we're going to also look at chemical changes. But before we do that, let's go ahead and more clearly define what matter itself is. Matter is anything that occupies space, or in other words, anything that has volume and has associated with it mass. Anything that has volume and mass then is matter. Well, I don't think you can think of anything that doesn't fit that category, probably. Whether we're talking about the particles making up the air, the molecules, they have mass, they occupy space, they're matter. The chair you're sitting on, the clothes you're wearing, the food you ate, every one of those is a piece of matter, and every one of those then is something that we're studying when we talk about chemistry and what changes it undergoes. When I ate the donut this morning for some energy, all right, what happened to the chemical, the matter in there, as it went through my body and was converted into energy so that I could get to school, I could become active, I could learn. All right, all of those are changes again that are occurring for matter. So anything that has mass and occupies volume. Now, occasionally we hear the term weight and mass, and quite often they're interchanged. But there is a difference between the two, and so we should at least identify what we mean by the two. Weight is dependent upon gravitational pull, and weight is dependent upon one location relative to the center of mass that you're being attracted to. In other words, I weigh a different amount at sea level than I do at Pikes Peak. I weigh a different amount if I'm in an airplane than if I'm in a ship. I can become weightless. If we look up here, a very poorly focused picture, if we look up here, we can see, for instance, that if we get in a spaceship, our mass, 60 kilograms, is the same as the mass on the Earth, 60 kilograms, the same as my mass on the Moon, 60 kilograms. But in a spaceship, I can become weightless, because if I get far enough away from the Earth's center, I no longer have any attraction for it and I become weightless. The gravitational force is no longer there. I never become massless. As a matter of fact, mass is a constant property of matter. Weight is a variable property of matter. All right? So mass, then, doesn't depend on our location. And that's why when we define matter, we say anything that has mass and volume. If we said anything that had weight and volume, then of course we can think of things that become weightless. We could become weightless, but we never become massless. All right? So notice that the mass on the Earth, the mass on the moon, the mass in a spaceship are all equal. It doesn't make any difference. Mass is, by definition, a resistance to being put in motion. It's a resistance to being then put into an inertial state, into a moving state. And we see there then small mass, which shows an empty grocery cart, doesn't take a whole lot of force to put it into motion. But if we load it full of canned goods, then of course it takes a whole lot more force to get it to go. So the mass has become greater. All right? Now, for typical purposes, if we're talking about working in the lab and we're fairly close to sea level, really the mass of the objects that we're working with and the weight of the objects we're working with are basically one and the same thing. So we often hear weight instead of it. But I have tried throughout the text to use the term mass wherever we're talking about that particular property. But occasionally you pick up a book, you read an article, you see something in a newspaper, and it talks about the weight of something. All right? That means something that has been measured in terms of gravitational pull. For our purposes, we will use mass, which is a non-variant than property of matter, rather than weight. Now, matter can exist in three different forms. We see here listed as atoms, molecules, and ions. Atoms are very, very small particles, and we'll talk more about atomic structure later in the semester. Actually, we'll talk about it in Chapter 6 quite extensively. But atoms are going to be our smallest unit. Molecules, then, by definition, molecules are the combination of two or more atoms. That makes up a molecule. Now, it doesn't say what kind of atoms, just two or more atoms. They might be the same kind of atoms, they might be different atoms. But the combination of two or more atoms then gives us molecules. And finally, the third way that we can find matter is in the form of what we call ions. The first two forms of matter here, atoms and molecules, are neutral. In other words, they do not have a charge associated with them. In contrast, ions are non-neutral, or we say charged objects. In other words, they're going to have either a positive charge associated with them or a negative charge associated with them. Atoms and molecules are electrically neutral. Okay? They're neutral pieces of matter. Now, in addition to thinking of matter in terms of atoms, molecules, and ions, in chemistry we further break matter down into a couple of other terms that we'll use frequently throughout the semester. The first of these are elements. Elements are one type of atom. All right, in other words, when we talk about an element, we're talking about a chunk of matter that contains one type of atom. Elements are called pure substances. They're pure substances. We can't separate out anything. We don't get different amounts of different materials. It's a pure substance, meaning that they're all the same. Now, when we talk about the atoms and the elements, we then talk about symbols. And this is especially true in chemistry, where we're talking about some way of describing this matter that we're going to study. And in chemistry, we don't typically just use words to do so. We use chemical symbols, which deals with the elements. We use chemical formulas, which deal with elements and compounds, which we'll define here in a moment. So in chemistry, we're going to be looking at really three things. The language of chemistry. We're going to look at the symbols of the elements. That's kind of like the chemistry alphabet. And then we're going to begin putting these symbols together, and we're going to make words, chemical words, which we call chemical formulas. And later on, we're going to take the alphabet and also these formulas, in other words, chemical words, and we're going to combine them together, and we're going to make sentences, which we're going to refer to as chemical reactions. Okay? So we're going to start by looking at the alphabet. We're going to move on fairly quickly and begin looking at chemical formulas in Chapter 2. And then in Chapter 3, we're going to go ahead and take then symbols and formulas and begin putting them together to talk about chemical sentences or chemical equations as we talk about it. Now the symbols we see up here in the periodic table of symbols. As far as your text is concerned, you will find a full list of the first 109 elements that are known. On page 514 in the text, this will be hard to have all of this in focus, but each element has its atomic number, as it's called, and the atomic number is a characteristic that identifies that atom as different than every other element in the periodic chart. And we'll talk again what this atomic number means in Chapter 6 when we talk about atomic structure. But you'll notice on this periodic table that we have posted on the wall here, then each of the elements has a number, upper left, then that is the atomic number, and then we have the symbol. And that symbol is the shorthand or the alphabet representing that particular element. Now, it would be certainly fun to learn all 109 elements and symbols, and quite a feat to do so. However, for practical purposes, we only need to work with about 30 some of the elements and their symbols. And so let's take a look at those. And those will be found in Table 1.1 in your textbook. Now, if we take a look at the first few here, aluminum, we see the symbol Al. That looks pretty good. Argon, Ar, barium, Ba, bromine, Br, calcium, Ca. Notice the first 5 elements that we see in that table, that the symbol is what? The first and second letter of the name. Okay? And that's true. A lot of the elements we use the first and second letter of the name. But one thing is important, and that is that the first letter is uppercase and the second letter is always written as lowercase. If not, instead of writing the symbol of an element, we may actually be writing the formula of a chemical compound. The textbook identifies what happens if we write a large C and a small o. If we do that, we see that that is element cobalt. However, if we write a large C and a large O, uppercase for both, that is not the symbol for cobalt. That is the formula for the chemical compound carbon monoxide. So it's very important to differentiate between uppercase and lowercase letters in these symbols. Carbon, we only have a single letter. Now, the purpose or the reason behind that is the first element that was named with the letter C was given the symbol C. So then when we found an element that was named like calcium, we couldn't use the C again because we already had used the C. And I say we, I'm not that old, okay? There were people that did this before my time. But they used then the first letter for the first one. When calcium was named, then of course again they couldn't use the C, but they used then the first and second letter, Ca. If they have a third, which we don't see on here, but is in the back of the book, and I'll just point that out on the chart to show you what does happen. If we look at this element here, number 48, that's cadmium, C-A-D-M-I-U-M. Well, we've already used a single C. We've already used a C and an A for the calcium. And now, of course, we can't use C and A for cadmium. So what do? They go with the first and the third letter to give the name or the symbol cadmium. Now that works pretty well for a majority of the elements as you begin studying them. And by the way, you are responsible for this and you need to work on this quite soon. And as the text indicated, one good way to do this is, if you're not familiar with these, make up a little set of 3x5 cards and cut them in half. One side write the symbol, the other side write the name. Spelling is important. Spelling is important, so be sure that you know how to spell it as well as what the symbol is. When we get to here, however, notice copper isn't CO, copper isn't CP, copper is Cu. Well, some of the elements are actually, the symbol is named not after their common English name, copper is what we call it today, but rather are named after their Latin or their Greek derivation or their Germanic, whatever the case might be. So some of these are named not in the name that we use today, but in the original name given to them. Copper was cuprum, as you can see, and that's where the symbol Cu came from. Gold is another good example. Gold, that's the common English name, but its original name was arum. And so the symbol for gold is Au, not a G, as we might predict. Again, some other exceptions. Here's iron is not an I, and that's one to pay close attention because that's one I see students miss frequently. They use I for iron. I is the symbol for iodine. And so you have to be careful there that you are not then putting down the incorrect symbol. You're using the wrong alphabet. Lead is another one. Plumbum. Two other ones that are frequently mixed up, magnesium and manganese. So pay close attention to those two, magnesium Mg and manganese Mn. Down here also, one other one that is frequently missed is potassium. People like to put the letter P for potassium, and that sort of makes sense, except that the letter P is phosphorus, and potassium has a symbol that really has very little to do with what we would normally think it should be. That, of course, is again the K, and that is from kalium, which was the original name for potassium. All right, wolfram, down here, tungsten, as it's called, was from the German Wolfram, and thus the symbol W. So you need to begin working on those symbols, as I said. You're responsible for that, and we'll probably have a little quiz on that one of these days real soon. So begin working on that. Now, the elements, we talked about the symbols here. Oh, should mention one person's name while we're here also. Berzelius who was a scientist who was interested in trying to get better communication between people working in the chemistry area. And there was a lot of inconsistency of what people were calling the same thing. I mean, a chemical that was being used in Germany might have been called something totally different than a chemical that was being used in England. Or an element used in Germany was different than an element used in England. And obviously, if scientists are going to communicate, and communication is very important in science, we have to have a common language. And Berzelius was very instrumental in getting the early chemists, the early scientists together to begin agreeing on certain symbols to represent certain elements. Okay, so he has a major contribution to us, and throughout the course we'll be looking at some individuals who have made some major contributions. All right, as I was beginning to say, the elements actually turn out to be found in three different forms, which we call monoatomic elements, diatomic elements, and polyatomic elements. Now, looking at the prefix here, the prefix mono means one. One atom elements. In other words, it means that the element consists of individual atoms. That's a monoatomic element. A diatomic, di is a prefix meaning two, and so actually those elements then exist not as individual atoms, but actually exist as molecules. Molecules containing two atoms. Okay, that's what diatomic means. And polyatomic, poly is a prefix that we use for many. So it could be 3, 10, 22, whatever. Polyatomic means then that those elements exist again in molecules, but containing 3 or more atoms hooked together to make up the element. We're still talking about elements here, but the elements can exist as an atom or as a molecule. Now, some examples of some of the monoatomic elements. Here's some here that are common. Aluminum, symbol Al. Iron, kind of a black powder, symbol Fe. Nickel, nice shiny metallic material there. Some balls, nickel, prefix Ni. Copper, it's a little hard to see this on the screen, but it does have the kind of reddish brown color that we associate with copper metal. These are all, again, monoatomic elements. Down here we have gold, symbol Au, silver, 99.9% pure silver metal here, symbol Ag. Lead, a kind of a blackish looking metallic material element, symbol Pb. And finally over here mercury, and of course its symbol is again one of those that's sort of unique, the Hg, which again comes from the Greek derivation rather than the common name of mercury. Mercury is unique from the standpoint that it is the only metal that is a liquid at room temperature. All of the other metals that exist in nature as elements exist as solids. Mercury exists as a liquid at room temperature. Very unique element. Okay? Matter of fact, there are only two elements that exist as liquids at room temperature. Mercury and bromine are the only two that exist as liquids at room temperature. The rest of them either exist as gases or solids, and as a matter of fact, just to give us some reference, hydrogen is a gas, nitrogen, oxygen, fluorine and chlorine, and then this last column over here called the noble gases. So if we look at it, we're talking about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 of the 109 elements are gases, 2 are liquids, and the remainder of them are solids at room temperature. So most of the elements are solids. When we talk about the study of matter, we're talking about the study of elements. We're talking, in most cases, about something that exists as a solid. These are some, as I say, examples of monoatomic elements. Now, diatomic elements, we have a series of diatomic elements that are important. In other words, this is the way we write them when we're going to write them in then chemical sentences and chemical equations and talk about them. They're nitrogen, which is written as N2, oxygen, O2. That little subscript tells us that there are 2 atoms making up the molecule. Fluorine, F2, chlorine, Cl2, bromine, Br2, and iodine, I2. Now, element 85, astatine would also be, but it is not one of the elements that we frequently encounter, so we're not going to worry too much about that. Oh, I forgot one. Yes. The reason I forgot it is just because of its location on the table. It's not close to the other ones there, and that's hydrogen. So, these elements that primarily are gases also are primarily diatomic. Hydrogen, nitrogen, oxygen, fluorine, chlorine, and then in addition diatomic bromine, which is a liquid, and diatomic iodine, which is a solid, and all of these monoatomic gases over here called the noble gases. We have only 2 polyatomic ones that we're going to look at, and that is phosphorus, which is 4 atoms per molecule. We call that a tetraatomic species. Tetra being the prefix for 4, a tetraatomic, 4-atom molecule. And the other one, which is S8, sulfur, and we refer to that as an octa, which is the prefix for 8, octaatomic molecule. Okay, so those are the 2 polyatomics that we might frequently encounter, P4, phosphorus, and sulfur, which exists as an S8 molecule, both examples of polyatomic. Now, the very last thing let me quickly mention then here are prefixes. Notice that we've used 3 prefixes here: mono, di, tetra, and octa. As we go throughout the course, we will find that we will use prefixes to talk about then the number of atoms in a molecule. Sometimes we'll be talking about the number of molecules in something. So these are the prefixes that we should become familiar with because we will encounter them throughout the course. Again, the prefix for 1 is mono. Prefix for 2 is di. We've already looked at those. 3 is tri. 4 is tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And the prefix for 10 is deca. And finally, if we have more than 10, we often just use the prefix poly, which stands for many. So when we talk about polymers, we're talking about many mers, whatever mers happen to be. Well, we'll talk about what that really represents in Chapter 2. But these are prefixes then that you should become familiar with because we will use them frequently throughout the course.